Hello everyone, my name is Amit Goyal and I am from the Department of Mathematics. Now today we discuss about the topic of sequence. The main reason of discuss the about of sequence is that when we study about the sequence, the one question arise in our mind is what is the use of a sequence in mathematics. Basically mathematics is use the all the field of in agriculture, basically in physics, in chemistry also. But now we take the study of the sequence in mathematics. Basically when we talk about the topic is sequence. What is the use of sequence in mathematics? Basically basically we talk about the this is the two term, sequence and other is series. When we see these two topics are similar, but by the definition these are not similar. The mean of sequence is the arrangement of n numbers. Basically we talk about the sequence, then we say that we arrange the nth term of a sequence. Nth term of sequence matlab means that we talk about the nth term like 1, 3, 5 and so on. This is going to go on infinity, but the series mean that we add the nth term. So this is the difference between series and sequences. In sequence we arrange the n numbers, infinity numbers, not a n number, we arrange the infinity numbers, but in series we arrange the we sum the infinity numbers like this and so on. So this is the minor difference between the sequence and series. Now we study about the sequence and series. Okay, now we start the main topic of our is sequence. So basically first we discuss about the definition of a sequence. Definition. The definition says that if a function from f n to r is called the sequence. Okay. Now we see that the domain of this function is natural number and the range of this number is a real number. So now we talk about the natural number. What is the natural number? Natural number is started from 1, 2, 3 and so on, and real numbers are have the positive number, real negative numbers and rational, irrational also. But when we see the definition of the sequence, we notice that the domain of function is n. It means that when you took the terms, when you take the terms, you take the natural number. It is denoted by xn. It is denoted by xn. Many books are represented like this, many books represented like this, like this. Okay. So these are the notation of a sequence where n is a natural number, where n is a natural number. Okay. So this is the basic definition of a sequence, and the first thing we all learned about this, the domain of the function is a natural number. We not use the other set of a number, we only use the set of natural number. Okay. Now we take the example of a we take the example 2 and 3 example for a sequence. Like example, we say that the sequence is 2n plus 1, n belongs to n, and the question is write down the terms of a sequence, write down the terms of the sequence. So we start the question. The solution is that we know the n is a natural number, and I know also that when the n is natural number, it is started from 1. So the terms of sequence is, when we put n is equals to 1, then the term is n1 plus 1. Okay. And if we take the n is equals to 2, the term is this, and we take n is equals to 3, the term is, and so on, because n is an infinity set and n have a infinity number. So we take the only 1, 2 and 3 and so on. So the sequence, what is the term become? 2 plus 1 4 plus 1, 6 plus 1, 6 plus 1 and so on. Okay, because 2 into 1 is equal to 2 into 2 is equal to 4 and 3 into 3 2 into 3 is equal to 6. Now xn is equal to 3, 5, 6 and so on. So this is the terms of a sequence. We say that this is the term of a sequence. The question is given that xn is equal to 2n plus 1 and we write down the terms of a sequence. Okay. Now this is called the first term of a sequence, this is called the second term of sequence and this is called third term of sequence and so on. So if we ask about the terms, then we say that 3 is the first term of sequence, 5 is the second term of sequence and so on, like the 6 is the third term and third term of a sequence. So if we go further, then we see that the nth term is n is equals to 2n plus 1. 1 second. Now we written here, if we take the n is an n, then this is the nth term of a sequence. Okay, this is the nth term of sequence and we here written that the nth term of sequence is denoted by xn. Okay, here the nth term of sequence is denoted by xn. So here we study about the how we write the term of a sequence. Suppose that if you give the xn, if you give the sequence, then then I ask to the what is the terms of a sequence. So this is the general method to write down the terms of a sequence. We take the another example, last example. We take the last example is suppose that xn is equals to minus 1 की power n and n belongs to n. Now we write the term of a sequence. So we written here, this is denoted by, the sequence is denoted by this and many pupils, many students are denoted like this. So these both are similar. Okay. So here we denote the terms of a sequence. If we know that here is n from natural number. So we know that the n is a natural number, then it is started from 1. So the term is minus 1 की power 1 because n is come from the natural number. So n is equals to 1 and minus 1 की power 2. This is the terms of a sequence and so on. So what is the term of a sequence is minus 1 का square minus 1 minus 3 cube minus minus 1 square 1 minus 1 is cube minus 1 minus 1 की power minus 1 power 4 is 1 and so on. Okay. So this is the terms of a sequence. So we study about the how we write the terms of a sequence. Now we talk about the types of a sequence. Okay. Here we write down the types of a sequence. Basically sequence have 3 types. Okay. Now we write the structure of a types of sequence. Here sequence have 3 types. Sequence have 3 types. First is convergent sequence, and second is divergent sequence, and second is auxiliary sequence. Okay. This is the auxiliary sequence. So there are 3 types of a sequence: convergent sequence, divergent sequence and auxiliary sequence. Here first we discuss about the convergent sequence. Here we discuss about the convergent sequence, after that we discuss about divergent sequence, and after that we have a discuss about the oscillatory sequence. Now we discuss about the convergent sequence. Okay, convergent sequence. But before convergent sequence, I discuss about the limit of a sequence, because this is an important part of a sequence, limit of a sequence, because without the concept of limit of sequence we do not find the convergent sequence. So here we discuss about, first we here discuss about the limit of a sequence. Limit of a sequence, because this is related to convergent sequence. Without this we don't know about the convergent sequence, because the convergent sequence is depend on the limit of a sequence. Okay. Now I am discuss about the convergent sequence, then I am tell you what is the relation between limit of a sequence and convergent sequence. But first we discuss about the limit of a sequence. So first we go for the mathematical definition of limit of a sequence. So the definition of the mathematical definition of limit of a sequence is, for all n belongs to n, you write like this: if xn va given sequence and for all n naught belongs to n such that mod xn minus L less than epsilon for all n greater than equal to n naught. This is the mathematical definition of a limit of a sequence. Okay. Now we discuss about the mathematical definition, but it is not easy to understand every student. If suppose that student are from arts background, then he don't know about the epsilon, he don't know about the n naught, he don't know about the mod, this is the mod function. So we now we have study about the geometrical meaning of a limit of a function. Here first thing I tell you that you write here the for all epsilon greater than 0, you here little write epsilon greater than 0. Basically epsilon is a positive number, we see the limit of a sequence in a geometrical manner like this. What is the mean of this? Okay, in geometrical meaning. Now if we solve this, we know that the mod function is open like this. If I say that x minus a less than b, then the mod function is open is x minus a less than b less than minus b. In if I add plus a in both three terms, then what is a minus b less than x minus a plus a less than b plus a. So a minus b, x, a say a cancel out, minus a plus b. So basically this is the open of mod function. Now we apply this method on this mod function, then what is the value of x? Okay, so we rough this. See, if we apply the method of open of a mod function, then what is the behavior of this xn? Suppose xn less than epsilon. So this is, if we open this mod, and we know that this is open like this. Okay. Now we add plus L from three terms. So L minus L less than xn minus L plus L less than epsilon plus L. Okay. Now we written here minus L cancel out plus L. Okay. Xn less than epsilon plus L. So this is the value of xn. It means that the range of xn is L plus L less than greater than L minus epsilon and less than L plus epsilon. So this is the range of xn. It means that the xn vary from L minus epsilon to L plus epsilon. Okay, listen. The terms of a sequence is lie from L minus epsilon to L plus epsilon. Now we see this is in a geometrical manner. See, suppose that here is the number is n naught. N naught is a natural number. This is the line of a natural number. This is the line of natural number. I suppose that here is n naught. Now we say that if suppose that this is the point of L, suppose that the sequence have a limit L, which is the point is here L. Now we say that if we go further, I see that when the term of sequence cross the value of n naught, he are come from around the L. This is the epsilon, this is the minus epsilon. Okay. Now we say that L is a limit of a sequence. So basically the concept of limit of sequence say that if a point is a limit of sequence, then we say that the infinity term of sequence are lie in neighborhood of L. Basically we say that if we go further, when we increase the terms of a sequence, if the terms of a sequence cross the number n naught, then we see that the sequence of term are lie between the neighborhood of L. So this is the limit of a sequence. Now we give the example of a limit of a sequence. Okay. See, like I give the example, suppose that xn is equals to 1 upon n. Okay. Now we find the limit of this sequence. Now we find the limit of this sequence. So what we do to find the limit of this sequence is, we have two methods. We have two methods to find the limit of a sequence. One method is general method and second method is mathematical method. So we discuss about both method here. First we find out the limit of a sequence by the general method, and other hand we find out the limit of a sequence in mathematics manner. Okay, in by the mathematics definition. Okay, first we discuss about the limit of a sequence in a general method. Okay, now so general method is, this is the basically high school method. This is the basically high school method, but when we discuss when we go further in graduation, we basically use the mathematics definition to find out the limit of a sequence. This is the high school method, so we not discuss much more about it, and we don't talk about it much more. So xn is 1 upon n. If we find the limit of this sequence, we take the limit from n tends to infinity both sides. We take limit n tends to infinity both sides. If I want the the limit of a sequence 1 upon n. Okay. Now see, limit n tends to infinity, here left hand side, limit n tends to infinity xn is equals to, here if we put n tends to infinity in this, then what is happen like this. If we put n is equals to infinity here, then this is become 1 upon infinity. We all know about 1 upon infinity is equals to 0. 1 upon infinity is equals to 0. So the limit of the sequence is 0. So now here the value of L is 0. This is the high school method, and this is the basic method of find out the limit of any sequence, any series, any function. This is the general method, high school method. Okay. So we repeat this method. What we do? We do that, given that xn is equals to 1 upon n, we take the limit n tends to infinity both side, and limit n tends to infinity, if we put the value of n tends to infinity here, then what is the value of 1 upon infinity is 0. So the limit is 0. Now we discuss about the find out the limit of a sequence in BSc, in sorry not a BSc, basically in graduation level, basically in mathematics manner. Okay. Now we find the limit of the second method is by the mathematically definition of limit. Okay. Now here we use the definition of limit to find out the limit of a sequence of function. This is the general method. Both method are right. The answer from both method are same, but this is a high school method, so we don't prefer it. but we basically most of us are prefer this method because this is the mathematically definition method. Okay, now the sequence is given is 1 upon n. What is the definition of limit? For all epsilon greater than 0, there exists n naught belongs to n such that mod xn minus L less than epsilon for all n greater than equal to n naught. The main aim to use this method is find out the value of n naught. The main aim of use this definition to find out the value of n naught. If we say that the n naught value are not exist, it mean that the sequence have no limit. Again I repeat, if I say that n naught has not exist, I say that n naught have not n naught not exist, then we say that the limit of a sequence not exist. So the sequence is not going to some limit. But if we say that the n naught is exist, then we say that the limit of a sequence is exist. So now we apply on this sequence of this definition is, we all know xn is 1 upon n. L is, we find out the L, we find the value of L is 0. We already find out the value of L is 0. So we put the value of L here is 0 less than epsilon. Okay. Now we solve it. 1 upon n minus 0 is 1 upon n. Okay. Now we know that n is a natural number. We know that we all know that the n is a natural number and natural number is positive. If 1 upon positive is always given a positive number, so the term inside the mod function is positive. So he open in positive manner less than epsilon, and now we solve it 1 upon epsilon less than n, n greater than 1 upon epsilon. So this is the value of n naught. This is the value of n naught. So here we say about the limit of a sequence is we find the n naught, we find the value of n naught. If the n naught value is finite, is the value of n naught is exist, then we say that the limit of sequence have a limit exist. Okay. Now we took the another example, last example. Okay. Suppose that xn is equals to minus 1 की power like this. Suppose that 2n plus 3 upon 3n plus 4. Okay. Now we find the limit of this sequence. So we go for a normal method, basically in high school method, then we take the limit n tends to infinity both side. (2n plus 3 upon 3n plus 4). Now we solve it. If we solve it, we see that if we take the common n from here, we take the common from n here and 3 upon n. Also we take the common n from here. So what happen? Like this, cancel out the n from n. Now limit n tends to infinity xn is equals to limit n tends to infinity 2 plus 3 upon n upon 3 plus 4 upon n. Now we put the value of n is infinity here. Limit n tends to infinity xn is equals to 2 plus 3 upon infinity upon 3 plus 4 upon infinity. We all know that 3 upon infinity is 0. The value of 4 upon infinity is 0. So here what happen? 2 plus 0 upon 3. Sorry, not 4, 3. 3 plus 0. So what happen? What is the limit of a sequence xn is equals to 2 upon 3. So this is the limit of a sequence. Okay, now we discuss about the we see the limit of the sequence is 2 by 3. So, this is the method of finding the limit of a sequence. Now, we come on our topic convergent sequence. Okay, now we come on our topic convergent sequence. Convergent sequence. First, we discuss about the definition of convergent sequence in mathematical way. What is the mathematical definition of convergent sequence? First we discuss about the convergent sequence in general manner. Basically, the convergent sequence is a sequence which have the finite limit. Again I repeat, if a sequence which have the finite limit is called the convergent. Okay. The mathematical definition is, if a sequence xn, then for all epsilon greater than 0 there exists n naught belongs to n such that mod xn minus L less than epsilon for n greater than equal to n naught. So, this is the similar from limit of a, this definition is look like a similar of a limit of a function, limit of a sequence, but it is not a similar. This is the big difference, because when we talk about the limit of a sequence, we never talk about the finite or infinite limit, but when we talk about the convergent sequence say that if a sequence which have the finite limit, then we say that the sequence is a convergent sequence, otherwise it is not convergent. Okay, I again repeat that when we talk what is the difference between a convergent sequence and limit of a sequence, because the definition of a convergent sequence and limit of a sequence look like similar, but it is not a similar. Why? The question is arise why. I am say that when we talk about the limit of a sequence, we say that the if a sequence which have a limit, it is finite or infinite, does not matter. But when we talk about the convergent sequence, it is necessary that a sequence which have a limit is finite, otherwise he is not a convergent sequence. If a sequence which have a finite limit, then we say that the sequence is convergent, otherwise if a sequence is not a finite limit, suppose that a sequence which have infinite limit, then we say that this is not a convergent sequence. Okay, I give the example to you. I give the example. Okay, I give the example. See, I say that example like I give the both example in further. Okay, I say that xn is equals to n upon n plus 1. Okay, this is the sequence which is given, and the question is that discuss about the convergence of a sequence. Discuss about the convergence of a sequence. So, I say that if the first step is to find the convergence of a sequence is find out the limit of sequence. Find the limit of sequence. Okay. Second step is check the limit is finite or infinite. Second step is first you find the limit of a sequence, second you check the limit finite or infinite. Step third, if limit is finite, then the sequence, then the given sequence is convergent. Otherwise, the limit is not finite, limit is infinite, right like this. the limit infinite, then this is not a convergent sequence. Okay. Now we discuss about this example and apply 3 steps on this. Okay, let's see what happened. Let's see. Given that xn is equals to n upon n plus 1, the first step say that find the limit of a sequence. So the sequence here is xn upon n plus 1. We find the limit of the sequence. How? N tends to infinity, xn is equals to limit n tends to infinity n upon n plus 1. Okay. Now we solve it and we find that limit n tends to infinity xn is equals to limit, we solve it, then we see that if we put the value of n is equals to infinity, then here is infinity, and now we put the value of n is equals to infinity here, then what is infinity plus 1? Infinity plus 1 is infinity. So this is undetermined form, because this is undetermined form, this is not exist in mathematics. So we solve it and we find that, and we take the common here, then 1 plus from here, then we find it this, n to n cancel, limit n tends to infinity xn is equals to, so what is the, we find, we got limit n tends to infinity 1 upon 1 plus 1 upon n. Okay. Now we put the value of n is equals to infinity here. So this is xn is equals to 1 upon 1 plus 1 upon infinity. We all know 1 upon infinity is 0. One upon 1 plus 0. So what is 1 upon 1 is equals to 1. So the limit of a sequence is the limit of sequence is 1. Limit of sequence is equals to 1. Limit of sequence is equals to 1. So first step is completed here. Now the second step say that check the limit is finite or infinite. Now we see that we got the limit of a sequence of function is 1. This is a finite number, 1 is a finite number. So we say that if the limit is finite number, then the sequence is convergent. Here the 1 is finite number, so this sequence is a convergent sequence. So we write here limit of given sequence is finite, so the sequence is convergent. Sequence is convergent sequence. Okay. This is the method to find the sequence is convergent or not. Okay, now we give the second example and last example. So second example is, let sequence is e की power minus nx for all n belongs to n. Here the sequence is e की power minus nx. Now we check this is a convergent sequence or not. So first step is say that first you find out the limit of the sequence. So now we find the limit of sequence is xn is equals to e की power minus nx. So we take limit n tends to infinity both side. We take the limit n tends to infinity both side. Sorry for that, here is x not come. Okay, the sequence is e की power minus n only, not x here. Now limit n tends to infinity xn is equals to, Here we put the value of n. What is the value of n? Is infinity. So we put the n value of n is infinity. So what happened? E की power minus infinity. I hope you know about the e की power infinity is infinity and e की power minus infinity is 0. I hope you all know about it. E की power infinity is infinity and e की power minus infinity is 0. So what is the value of e की power minus infinity is 0. So the limit of a sequence is 0. The value of limit is 0. The first step is complete. The second step say that check the limit is finite or infinite. We all know 0 is a finite number. 0 is a finite number. So we say that here the limit of a sequence is a finite number which is 0. So the given sequence is convergent sequence. So here we write here. Write here the given sequence. The given sequence is finite, have finite limit, have finite limit. So the sequence is convergent sequence. Okay. So it's all about the convergent sequence. I repeat the method of convergent sequence. What is the convergent sequence? Convergent sequence say that if a sequence which have the finite limit, then the sequence is convergent sequence. How we find? If suppose that you give a sequence, first you find the limit of that sequence, and second step say that you check the limit is finite or infinite. If your limit is finite, then the sequence is convergent. If your limit is infinite, then the sequence is not convergent sequence. Okay. So this is all about the convergent sequence. Now the question is arise that if the sequence have a finite limit, then we say that the sequence is convergent. Suppose that if the sequence have infinite limit, then what we say about the sequence? If sequence have the infinite limit, then what we say about the infinite? Sorry, what we say about the sequence. So now we discuss about the divergent sequence. Okay, when you find the limit of a sequence, if your limit is infinite, you find the limit is infinite, then this is then the sequence is called divergent sequence. So relate in both divergent and convergent is convergent say that if the limit is finite, then the sequence is convergent, and divergent say that if the sequence have infinite limit, then the sequence is divergent. Okay. Now we write the definition of divergent sequence. Okay. See what I say, convergent, here you write convergent and here you write divergent. What is the difference between convergent and divergent? Only single difference between convergent and divergent. What is? Convergent say that if the limit of sequence, if the limit of sequence is finite, then the given sequence is infinite, then the given sequence is convergent sequence. Okay. Divergent sequence just opposite from convergent. Convergent say that if the sequence have finite limit, then sequence is convergent. If the sequence has infinite limit, then the sequence is called divergent sequence. So this is the opposite of convergent. Here you write that if the limit of sequence is infinite, then the sequence is divergent sequence. Okay. So you see that this is the opposite of each other. Convergent say that the limit is finite, then the sequence convergent. Divergent say that if the limit is infinite, the sequence is divergent. Okay. Now a little confusion from for the student here. When we talk about the divergent, when we talk about the infinity, then it's mean that if the limit is minus infinity or infinity, if the limit is minus infinity or infinity, this is the counter as a infinity. So this is the divergent. Okay, I give the example of this the divergent sequence, then you clear the picture of what happen in divergent sequence. Okay, so example is, suppose that the sequence is suppose that the sequence is n. Let the suppose that a given sequence is n. I write clearly here. Okay. Now the step are like a convergent sequence. First step say that find out the limit of the sequence. Second step said that check the finite or infinite limit. Third step say that if the limit is finite, then this is divergent sequence. If the limit is if the limit is finite, then the sequence is convergent. If the limit is the infinite, then the sequence is divergent. Okay. So same step we follow. First we find out the limit of this sequence. Okay. So we know that we put the value of n. What is the value of n? Value of n is infinity. So we put here infinity. Then what we know, what we find? So here we put the infinity. Okay. So what is the value of L? The value of L is equals to infinity. We all know infinity is a infinite number. Infinity is a infinite number. So what we say about the sequence? Sequence is divergent, because divergent definition say that if the limit of a sequence is infinite, then the sequence is divergent sequence. Here we look here we see that we find the limit of this sequence. We notice that the limit of sequence is infinity. So this is the divergent sequence. We simply say that this is the divergent sequence. Okay, this is the divergent sequence. Okay, now I give the second example. Now I give the second example is, suppose that a sequence xn is equals to, suppose that xn is equals to minus n square upon n plus 1. Suppose that the given sequence is minus n square upon n plus 1, where n come from natural number. We all know about the natural number, because the sequence definition say that here the n we use are come from natural number. So this is not a much more discussion topic, only we talk about the limit and convergent and divergent. Okay. Now if we find the limit of the sequence, so let us see what I got. The limit of this sequence is, here we take the limit n tends to infinity both side, minus n square upon n plus 1. Okay. Now if we check the given terms is determined or undetermined form, then if you want to see that this is the determined or undetermined form, you put the value of n. If you put the value of n here infinity, then you got minus infinity. Okay. Here if you put the value of n infinity, then infinity plus 1 is infinity. So basically you got the undetermined form. So this is necessary to solve it. Okay. Okay, now we solve it. So we find limit n tends to infinity, xn is equals to limit n tends to infinity minus n square. If we take the common from n here, 1 plus 1 upon n. Okay. Now we cancel out the 1 n from 2. So what we have, what we got? We got limit n tends to infinity. Here we got minus n upon 1 plus 1 upon n. Okay, now we put the value of infinity here. Now we put the value of n. What is the value of n? Is infinity. Now we put the value of n here. Then what we have, xn is equals to, here is minus infinity and here is 1 upon infinity. We all know about the 1 upon infinity value is 0. So we write here minus infinity upon 1 plus 1 upon infinity. The value of 1 upon infinity is 0. So limit n tends to infinity, xn is equals to minus infinity upon 1 plus 0. So what we value of a limit is minus infinity. So L is equals to minus infinity. So we know that the limit of this sequence is minus infinity. That is the that is the infinite number. That is the infinite number. So the given sequence is divergent. Okay. Now you are able to differentiate the convergent and divergent sequence. Now you are able to differentiate difference between convergent and divergent. Convergent sequence say that if you suppose that if you given a sequence and the question is that discuss about the convergent and divergent of the given sequence. So first you find the limit of that sequence. Okay. Now you check the limit is finite or infinite. Suppose that the limit of that given sequence is finite. So we say that the given sequence is convergent. Suppose that the limit of the given sequence is infinite, then we say that the sequence is divergent sequence. So this is the basically convergent and divergent sequence. Now we discuss about the next type of sequence is oscillatory sequence. Basically oscillatory means oscillation. Basically oscillatory means oscillation, when the terms of a sequence oscillate between two number. I tell the basic definition of oscillatory because we have no mathematical definition of a divergent sequence and oscillatory sequence. This is basically telling in general manner. So what is the general manner? Oscillatory sequence say that if the terms of a sequence oscillating from between two number like this. Suppose that I say that suppose that here is 1 and here is 2 on real line on x axis, then we say that if the sequence term, if we say that the sequence term is oscillating between 1 and 2, he start from 1, he goes 2, he goes on 2, after that he return from 1, after that he goes to 1 2 1 like this. When the terms of a sequence oscillate between two number, then that sequence is called oscillatory sequence. This is the basic definition of oscillatory sequence, not a much more typical language typical definition. This is the basic definition, and it is clear from the example. It is clear from the example. So I give the example of oscillatory sequence. I again repeat the definition of oscillatory, and I again repeat the the method to find the oscillatory sequence is that if the sequence oscillate between two number, if the sequence terms oscillate between two number, then we say that the sequence is oscillatory sequence. Otherwise this is convergent or divergent. I don't know what happened, but this is the general method of finding the oscillatory sequence. Okay, I give the example of oscillatory sequence. So now we topic is oscillatory sequence. The topic is oscillatory sequence. If you want to write the definition of oscillatory sequence, you write here that if the terms of a sequence is oscillate between two number, then the sequence is called the oscillatory sequence. You write a simple manner, okay, in which you want that. Okay, so this is the oscillatory sequence. I give the example and introduce the oscillatory sequence. Suppose that the sequence given sequence is minus 1 की power n for all n belongs to n. Okay. Suppose that the given sequence is xn is equals to minus 1 की power n. Okay, this is the given sequence. Now we write the terms of a sequence. If you want to check the oscillatory sequence, first you do that, you write the terms of sequence. Okay, you always remember that if you want to check the sequence is oscillatory, you write the terms of a sequence, because without the term of sequence you never told the auxiliary nature of a sequence. So the first thing what you do, you write the terms of a sequence. So here we write the terms of sequence. What is term of sequence? We know that n comes from natural number, and we all know about the natural number is started from 1. So what is the first term is minus 1 की power 1, second term is minus 1 minus 1 raised 2, third term is minus 1 raised 3, fourth term is minus 1 raised 4, fifth term is minus 1 raised 5, and so on. Okay. So now what is the terms of a sequence? Minus 1 raised 1 minus 1, minus 1 raised 2 1, minus 1 raised 3 minus 1, minus 1 raised 4 1, minus 1 raised 5 minus 1, and so on. Okay. Now here you notice that the terms of sequence lie between minus 1 and 1. This is the lowest term of this sequence is minus 1, and the highest term of this sequence is 1. So here we clearly notice that the term of sequence is lie between two number. The number is minus 1 and 1. You notice that here, suppose that minus 1, here 1, the first term is minus 1, he started from here, the sequence are started here. The second term is 1, it means that he goes from to 1, and third term is minus 1, it means that he returned from minus 1. The fourth term is 1, he go for 1, and after that he come from minus, so he oscillate from minus 1 and 1. So this is the auxiliary sequence. This is the rare example and a very good example of auxiliary sequence. So this is auxiliary sequence. Okay. So you notice that if the sequence, the terms of sequence lie between two number and repeat between two number, oscillate between two number, that type of sequence is called the auxiliary sequence. Okay, I give the another example of auxiliary sequence. Okay, okay, like this. Suppose that okay, sequence xn is equals to sin n. Okay, suppose that the given sequence is sin n. We all know about the highest value of sin n is 1, the lowest value of sin n is minus 1. We all know the graph of sin x is, we all know the graph of sin x is this. Okay. Here we notice that the highest value of sin x is 1, the lowest value of sin x is minus 1. If we draw, if we take, okay, I draw the graph carefully because I see one things in graph. Like this. Okay. So here the highest value is 1, the lowest value is 0 comma minus 1. Okay. Now we see that the highest value is 1 and lowest value is minus 1. The all value of sin x are lie between minus 1 and 1. You notice that from graph the whole value, if you write the term of sin, you notice that the value of sin are lie between minus 1 and 1. He is not go outside from 1, he not go outside from minus 1, he is lie always between minus 1 and 1. So we say that the given sequence is auxiliary sequence. Okay. Now we say that simply because we notice that the terms are between minus 1 and 1. So we easily say that this is the given example is the given sequence is auxiliary sequence. So this is all about the sequence. Now I told the use of a sequence. So when the mathematicians work on numbers, then he realized that because you know that the number we have no we have much many numbers in our planet, infinity numbers are exist. So mathematicians realized that to study all numbers are not possible, so he give the he give the topic of sequence to study about the functions which are apply on natural number, because you know that functions have many types, it is not easy to study each individual function because it take time. So the mathematicians give the topic of concept of sequence to study of function which apply on natural number, and range is real number. So that is the use of a sequence. Okay, this is the topic of sequence, and now we complete our my class, and I give the example of a convergent sequence, divergent sequence, and oscillatory sequence. And I told you the limit of a sequence. What is the sequence? First I told you the when I class start I am told the what is the sequence. After that we discuss about the limit of sequence, and after that the limit of sequence we discuss about the type of sequence. We discuss we talk about the type of sequence. There have three types of sequences. One is convergent sequence, and second is a divergent sequence, and third is oscillatory sequence. The convergent sequence say that if a sequence which have a limit is finite, then the sequence is convergent sequence. The divergent sequence say that if the limit of a given sequence is infinite, then the given sequence is infinite. And oscillatory sequence say that if the terms of a sequence vary from one point to another point, it means that the terms of a sequence lie between two number, oscillate between two number, then the given sequence is the oscillatory sequence. So this is the all conclusion of our class that which are discussed in today class. Okay, now we complete our class. Thank you students. Okay, thank you.